Hello, Anusha.
Okay, can you hear me?
Yeah, I can. You are on
All right.
mute.
Yes, I was on mute. All right. So let's talk about correlation. What does correlation mean?
That one thing has an impact on the other, or one thing is
Yes,
dependent on the other.
it's a relationship between two variables. Yes,
Yes.
it shows a relationship between two variables.
Yeah.
For example, I tell you that dim light leads to studying in a dim light leads to lower grades. Okay.
Yeah.
So I'm saying that there is what am I saying? I'm saying there's a relationship between these two variables
Yes.
where the first variable is my dim light and the second variable is lower grades. I'm
Yes.
saying the dimmer the light will be, the dimness of the
For the
light
grade.
is related to the grades. Yes.
Yes.
So if the light is dim,
The grade
the
will
grades
be.
will be lower. Yes.
Yes. Yes.
What kind of a relationship is this? When one increases and the other decreases? This shows a negative correlation.
Okay.
What is a negative correlation? When one variable increases, the other will decrease. So it is either called a negative correlation or it can also be called an inverse relationship. Yeah?
Okay. Yeah.
What is the inverse relationship? When one variable increases?
The other decreases.
Yes. The other will?
Decrease.
Yes. Or if one variable in decreases, the other
The
will?
other will increase. Increase.
Yes. So they go in the opposite directions, okay? It's a negative correlationship. When
Yeah.
one will increase, the other will decrease. If the other is increasing, this one will decrease. All right.
Decrease.
What if I give you another example where I say, for example, working out leads to a healthy individual. What are my variables right now? It's working out. So the more you will work out, the healthier you'll be. Yes?
Yeah. Yeah.
Yeah. So what kind of relationship is this? This is known as a positive correlation.
Okay.
Or it's known as a direct relationship. Okay.
Okay.
What does a direct relationship mean? They will go in the same direction. Okay.
Yeah. Mm-hmm.
So when variable 1 will increase, variable 2 will also increase. When variable 1 decreases, variable 2 will also decrease. Are you clear till here?
Yeah.
Okay. All right, now let's talk about independent and dependent variables. There is a variable known as an independent variable.
Mm.
And there is one variable known as a dependent variable. Do you have any idea what an independent variable is?
Yeah. So excuse me. So independent variable is that that it's not the one that is being impacted, but dependent variable is like if something happens to it, it will influence that variable then.
Okay, Independent variable is any variable that is not affected by anything else. Okay. It is set independently. Any variable
That is not affected by it.
it is set independently of the other variable. For example, time. Is time affected by anything?
No.
No, right? It works independently. No matter what we do, no matter what we are doing, the time will go on. So it is
Yes.
an independent variable. What a
Yeah.
dependent variable is, whose values are dependent on the independent variable.
Yeah.
Okay.
Mhm.
One whose values are determined by the values of the IV. IV is the independent variable, all right? Now, when you will plot a diagram, when I will ask you to plot a diagram, how will you plot this? The independent variable will always come on the x-axis. Okay, whatever the independent variable is, it will come over here.
Okay.
Okay,
And
and
then
whatever the dependent variable is, it comes on the
yeah, x-axis.
y-axis.
Sorry. Yeah.
Okay,
Mm-hmm.
let's talk about scatter diagrams now. Do you know what scatter diagrams are?
Yeah.
Scatter plots. What
Yeah.
are
The
they?
dots on the graph.
Okay, scatter plots. So scatter plots, you can basically through scatter plots you can represent data where. All right, you can represent data through scatter plots where the diagram shows the results from an experiment. Okay, it
Mhm.
will basically scatter plots will show you the correlation between the variables.
Yeah. Okay.
Okay? So let's draw a scatter plot over here. So for example, I am drawing a scatter plot for, this is a experiment of how breath rate affects pulse rate. Okay,
Mhm.
what is my IV over here?
How breath rate affects pulse rate. So we're gonna be talking about breath rate is gonna be the independent.
What are my variables? The variables are breath rate
Breath
and
rate
pulse
and
rate. Yes.
yeah.
So my independent variable is always what we think, what we looking at. So we're looking at the breath rate.
Mhm.
This is my IV. The DV is always the variable which we want to see the effect of. Okay, effect on.
Yeah. Effect
This is
on.
the IV is what we see the effect of, and the DV is the pulse rate which we are seeing the effect on. We are
Mm.
seeing the effect of breath rate on pulse rate, which is
Yeah.
why pulse rate is my DV. Are you clear with IV DV?
Yeah. Yeah. Yeah.
So what will come on my x-axis?
X-axis will be breath rate.
Yes, breath rate. So I'm going to write breath per minute because they're being measured per minute. And on my y-axis, I will write pulse rate. Okay.
Yeah.
So for example, you have 15, 20, 25, 30, 35. Okay. And for pulse rate, I have 40, I have 60, 80, and I have 100. Now when marking on the scatter plot, we mark x's. Okay, so for example, these are basically the points. Okay, I'm just plotting it randomly right now, but you will get a table for it. Okay.
Mm-hmm.
So for example, this is the scatter plot I get. All right.
Yeah.
On scatter plot, you just plot the points. Okay.
Yeah.
So from this scatter plot, we can see that where the axis, each x cross represents a data point. Okay. So let's write this. So this means, so for example, if I look at this point, okay, so you can see that at 15 breaths per minute, the individual had a pulse rate of 60. Do you see this?
Yes.
Okay. All right. So this is how we draw a scatter plot. Okay. Now different scatter plots will give you different correlations. This is what we said before, that scatter plots allow us to look at the correlations between the variables. So let's look at the different scatter plots that we can see. Okay.
Mm-hmm.
So the first type is for example, it's drawn like this. Okay. This type of a scatter plot is known as a, can you see if it's a positive relationship or a negative relationship?
Negative.
Negative, yes. So
Yeah.
this shows a strong negative relationship.
Yeah. Okay.
How do I know it's strong?
It's going downward sloping.
No, it's not going backwards because the
You said downward sloping.
the points are close to each other. That's how I know it's strong.
Okay.
Okay. Downwards it's going, which is showing us a negative relationship. Yeah. For strong, the closer the points are, the stronger the relationship is.
Mm-hmm.
For example, you have this. What kind of a relationship do you think this is?
This is like,
First is to know if it's strong or weak.
it's
Are the
weak.
points close together? It's weak.
No, it's weak.
Second is to know if it's positive or negative.
Negative.
What is the slope? Yes, the slope is negative, so it's a
Yeah.
negative relation. Understand now?
Yeah.
Okay. Another type of diagram is now, let's look at strong positive. Okay. So do you see the points are close together and the slope is positive? Yes.
Yes.
Over here, the points are far apart and the slope is positive.
Yeah.
As long as the slope is positive, it will be a positive. We can strongly know through the closeness of the point. So this is a strong positive. You can either write relationship or you can write correlation. Okay.
Yeah.
This is a weak positive correlation. One last type is this. What kind of a relationship do you think this is?
There's no relationship.
Yes, so this is a no or zero correlation. Okay.
Okay.
Are you clear till here?
Yep.
All right. Okay, let's move forward. Let's do some examples, okay? Now in these questions, they will ask you to determine the relationship between the variables. These are very simple questions. Let's do one of them. All right, so the question says, in a study of a city, let me just write down the question.
The population, something in people. What is it? Sorry.
Do one thing, Khadija. Can you open page 96 of the book I sent you? So it's easier for us to do it. Let me just draw the diagram. Have you opened it?
Yes.
Okay. Just read the question.
When I open page 96, it's all about arithmetic sequences and everything like that.
Okay, wait. I'm sending you another book for stats. Just give me a minute. All right. So this is basically, can you look at this table?
Yeah, I'm looking at it.
Yeah. Okay. So this question says, in the study of the city, the population density, this is the population density. The population density in people per hectare and the distance from the city center in kilometer, distance is this one, was investigated by picking a number of people of sample areas with the following results. Now, with this information, I want you to draw a scatter diagram. Can you do this? Do you have a graph paper?
It's okay. I'll just draw it on my booklet. Is that for I, is the distance 4.0 or 40?
4.0.
So for right now, for this is what I'm doing for, am I making it for a distance or distance and population density, right?
Yes. Tell me which will be my independent variable and which will be my dependent variable.
Okay, can you read the question again? Sorry.
In the study of a city, the population density in people per hectare and the distance from the city was investigated. Draw a scatter diagram for the information.
The distance will be the dependent variable.
The dependent variable, can you go back to independent variables definition? So what did we talk about in independent
Oh, no,
variable?
because because we're looking at the distance. So that will be independent variable.
Yes, the population density is basically the people per hectare. So the population density is affected by the distance, yes?
Yes.
My distance is my IV because it's not affected by anything. My
Yeah.
population density is the dV.
I'm just noting down. Can you move forward? I want to see the numbers.
Yes. Have you copied the table?
Yeah. Minus 1.8. And I is okay. Yeah, it's a very weak negative relationship.
Okay, just give me a minute. Okay. It's a weak negative relationship?
Yeah.
Okay, great. So let me just share the screen with you. All right. So your graph would be something like this, yeah? Yeah.
Yeah.
Now what I want you to do is I want you to interpret this answer. Interpret it. So my distance will come over here. So when they ask you to interpret the answer, you will apply it to the information they've given you.
Okay.
So in this with this information, how can you apply it?
We can say as distance increases, the population density increases as well.
It increases or decreases?
Sorry. Yeah, decreases. That's what I meant to say.
Yes, that is what you have to say. Do you understand?
Yeah.
Okay. Let's try to do this question. So they're saying Hidako wanted to see if there was a relationship between what people earn and at the age at which they left education or training. So what are his variables?
What people
Earning,
earn
yes,
and
and age of leaving
age
school,
they
yeah,
age. Yeah.
education. Okay. So he wanted to, what is my IV and what is my DB? What do you think?
So because they want to see what people earn, so that's gonna be your IV.
That is my IV?
No, that's your DV because it's depending
Yes,
on what age they leave at. Yeah.
yes. So what is my DV?
What people earn.
Yes, this is my DV because this is the effect they want to see. And what is the effect of? It's the effect of the age of leaving education. Yeah.
Yeah.
He asked 14 friends to fill in an anonymous questionnaire and recorded the results in a scatter diagram.
Yeah.
Describe the type of correlation shown. Let me just show you the diagram. Just give me 1 minute. Let me just show you the diagram.
That's
I'm sending you the PDF, all right?
sure.
All right. Can you open page 97?
Yeah, it's just loading. Yeah.
Yeah.
Yeah. So okay. It's a negative weak relationship.
Yes, it's a weak negative relation. Okay, let's look at part 2. They're saying Hideko says that her data supports that her data supports the conclusion that more education causes people to earn a lower hourly rate of pay. Give one reason why Hideko's conclusion might not be valid. Now, what is she saying? She's saying that her data supports the conclusion that more education causes people to earn a lower hourly amount of pay. She's saying there is a negative relationship. Okay, but we have found that there is a weak negative correlation. Yeah.
Yeah.
So it is not true that always when people will be more educated, they'll earn lower. Yes, this is what
Yes.
we mean by weak relationships.
Yes.
Yes. So
Yeah.
what can you write over here?
So we can talk about how like we see that after a certain age, then it kind of becomes more stabilized. So we could talk about like it says here as well, respondents who left education later would have significantly less work experience than those who left education earlier.
You basically have to give give any reason why a person leaving a education later can also earn a higher rate of pay. Okay, you
Mm.
have to just prove that this negative relation is not always true.
Oh,
Understand?
yeah. Okay.
Yeah. So this exercise 5A, this is all about this. All right.
Mm-hmm.
Okay. It's or everything over here is to do with this. All right. Let's look at. Let's do correlation. Let's look at linear regression now. Okay.
Okay.
Okay. All right. So when a static diagram shows correlation, you can draw a line of best fit. This is a linear model that approximates the relationship between the variables. Okay. So what is a line of best fit? They're basically saying, for example, this is my scatter plot, all right?
Mm-hmm.
A line of best fit is basically any line that you can draw through these. It's a straight line which you can draw through these points.
Oh, okay.
Understand?
Okay.
Okay, this is a line of best fit. You try to fit it as best as you can through the points. All
Mm-hmm.
right. One type of the best fit that is useful in statistics is least square regression line. All right, you don't need to know this. Okay. All right. Now there is a formula for the regression line, which has an equation of y is equal to a plus bx. Over here, b is basically the change in y for each unit of x, which is what? According to my equation of y is equal to mx plus c, what is b? B is
Why?
my m. Yeah,
Yeah.
B is my m. So B is basically the gradient. What is the definition of a gradient? It is any change in, what is the definition of gradient?
So it's the slope.
In
Slope.
y. Yes, it's a rise over run, which means any change in y tells you
Change.
the change in y for each change in x. Yeah?
Yeah. Yeah.
All right. So if my data is negatively correlated, what will B be? B
Will be
will
a
be
negative.
negative.
Yeah.
Yeah? because
Yeah.
that means negative correlation means a negative slope,
Yeah.
and negative slope means negative gradient. Yeah.
Yeah.
Which means my m value has to be negative.
Yeah.
Yeah. So B will be negative. All right. If my data is positively correlated, then what will my B value be?
Positive.
Yes, I will have a positive V value. Why? Because my slope will be positive.
Yeah.
Yeah, M will be positive.
Yeah.
So positive gradient. Are you clear till here?
Yeah.
Okay. All right. So let's look at example 3 on the next page. Example 3 says the daily mean wind speed W knots and the daily maximum gust G knots were recorded for the first 15 days in May. Okay, in UK. All right. So they've
Where are you
given us
reading this?
page 100.
Yeah. Okay.
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 Yeah. All right. So they've given us the information for wind speed, which is W knots, and the maximum gust, which is G knots.
Yes.
Okay. Now they are saying the data was plotted on a scatter diagram.
Yeah.
Okay. So in the scatter diagram, on the x-axis, they've written W naught, on the which is wind speed, and the gust is G naught. What is gust?
It's the daily maximum gust.
Yes, gust is basically the amount of dirt and the sand in the air. All of that dust is called gust. Okay. So they're basically saying that the wind speed, which will be wind speed, will lead to the dirt.
Yes.
Yes. Yes, that
Yeah.
is why the W knots, the wind speed is my independent variable. So it's on
Yeah.
the x-axis. You need to determine this, okay? Because they will not always give you the diagram.
Yeah.
Sometimes you will have to draw it. And the gust, which is the dependent variable, it will be on the y-axis, okay?
Mhm.
So in the first part, they're asking you describe the correlation between the daily wind speed and the daily maximum gust. What is the correlation you can see?
So as the wind speed increases, the amount of gust increases as well.
Yes. What is the correlation?
Strong positive correlation.
Yes. Why is it strong?
Because the points are very close together.
Yes, exactly. Understand?
Mm-hmm.
Now, the second part, the equation of the regression line of G on W for these 15 days is this. So they've now given you the regression line that you're talking about. Okay, G is equal to 7.23 plus 1.82 W. Give an interpretation of the value of gradient of this regression line. Where is the gradient? What is the gradient of this regression line?
1.82.
Yes. So what can you determine this? Can you interpret this gradient? How do you interpret gradient? You just say that it's 1.82. Firstly, you will explain, your first explanation will be why is it positive? Okay. You will say that it's a positive correlation, which is why it is a positive value. Okay. Second, you will apply to the information they've given you. Okay. So you will say as the wind speed increases, there will be more gust. Understand?
Yeah.
All right. So this is what you will write. You can also give an example from any of the points, okay, to explain this.
Okay.
There are two things you will do. First, you will explain why is it positive, and second, you will do an application.
Yeah.
In the third part, they say justify the use of a linear regression line in this instance. Now they're asking you, why is there a linear regression line?
Yeah.
Okay, so what will you say? That it is a correlationship that is being shown on the diagram, which can be plotted with a line of best fit. This line of best fit is actually a linear relationship. Understand?
Yeah.
Okay, you just have to give any logical reason and they're going to mark you correctly. That is the advantage of statistics. Okay,
Okay.
as long as you're using logic, there can be multiple answers for a question. Okay,
Yeah.
all right. All right, let's move forward. All right, let's look at question 4, example 4 on 101.
Yeah.
All right, first let's talk about interpolation. What is interpolation? It is basically making a prediction based on the value outside the range. Okay.
Yeah.
Okay. It's making a prediction based on the values they've given you.
Yeah.
What does this mean?
Could this mean like if let's say if there's sorry, go ahead.
Yes. So what are you saying?
I was gonna say like if there's like a graph already plotted and it's going in a positive, strong way, you know the next point is also gonna be a bit higher, maybe just like around that line.
Yes. Okay. So basically what regression means is when we talked about, this is the line regression, yes?
Yes.
The word regression, when we talk about regression, it is basically referring to prediction. So what does this prediction mean? When I find out from these are the existing values, right? When I plot the scatter diagram, I plot it based on the existing values, yes?
Mm-hmm.
When from those existing values, for example, I determine that right now the current relationship is a positive relationship, a strong positive correlation, okay, between the variables. Now, in the future, if I make a prediction that it is a strong positive correlation right now, this means that in the future also, if one variable increases, the other will increase. This is called interpolation because I'm making a prediction based on the values I have right now.
Yeah,
Okay,
makes sense.
I'm
Yeah.
actually assuming a relationship now, right? Because this relationship can change.
Yeah.
Yes.
Mm-hmm.
Okay. So, for example, if I say that studying at night results to better grades. Okay. So this is
Yeah.
a conclusion I'm determining by what? By the current data that I have. For example, I get very good grades in my O levels by studying at night. So I just determined that by studying at night, I study better and I can get good grades. Okay. But then
Yeah.
I go into my A levels and then I study at night and I don't get good grades. So this means this relationship can change. Yes.
Yes.
But what I did in my O levels was I did a regression. I made a prediction. This prediction was known as interpolation. You understand?
Yeah, makes sense.
Okay, great. Let's move forward. So these regression lines, why do we make them? We make them to make predictions only, okay?
Okay.
All right, let's look at example 4 on page 101.
Yeah.
It says the head circumference y centimeter and the gestation period x weeks for a random sample of 8 newborn babies at a clinic was recorded. So they've given you gestation period and they've given the head circumference, all right?
Mm-hmm.
So they're saying the scattered diagram shows the results. What is the relationship that you can see from the scatter diagram?
It's a weak positive relationship
It's a weak positive relationship, yes. Why is it weak?
because the points aren't close together.
Yes, they're not close together. And you see when I make a line, not all points are touching the line. Very less
Yeah.
points are touching. This
Yeah.
also shows a weak relationship.
Yeah.
Okay, the equation of the regression line is this. They've given you the equation. What is my gradient?
0.624.
Perfect. From the gradient also you can see that it is a positive relationship.
Yes.
The regression equation is used to estimate the head circumference of a baby born. Now when they use the word estimate, this means what? You are estimating, you are
Interpolation.
predicting.
Yeah,
Yes,
interpolation.
interpolation, you are predicting. So I determine my regression line equation, this equation that they've given you, what is it called? It's called your regression line equation. Yeah,
Yeah.
this is my regression equation. Now I will use this equation to make predictions. All right.
Yeah. Mm-hmm.
Okay. Okay, so now how can I make predictions from this? I can put in any value of y or any value of x and get the other value. Yes? This is
Yes.
how we make predictions. So now they're saying the regression equation is used to estimate the head circumference of a baby born at 39 weeks and a baby born at 30 weeks.
Yeah.
Okay?
So I'll just plot in 39 for x and then 30 for x
Yes.
to find the y.
Yes.
Yes.
So now what are they saying? First, they're looking at the they're asking for comment on the reliability of these estimates.
Mm-hmm.
So now we have to comment on the reliability of these estimates. How will we do this? Firstly, for 39 weeks, can you see 39 weeks on your chart?
Yes.
No, right? But
No, you
it's
can't.
not
It's
there.
38. Yeah.
But you can see it on your scatter plot. Yes.
Yes.
Yes. So this is a reliable estimate. Why? Because it's close enough. Yeah.
Yeah.
If it's close enough, also we also call it an interpolation. Okay.
Okay.
Close enough to the values you have, you call it interpolation. Now let's look at extrapolation. Extrapolation is when you predict outside the range.
Okay.
Okay.
Mm-hmm.
Just give me a minute. Predictions made outside the range.
Yeah.
Okay, if I'm making very far off predictions, it's called extrapolation and it is less reliable.
Okay, so like if I make a prediction of like 50 weeks or something like
Yeah,
that, then
it
that
will
would be
be less reliable because it's not on my scatter diagram.
Yeah.
So the
Okay.
39 weeks. So for 30 weeks, can you see it's very far off. 39
Yeah.
weeks is closer, yes?
Yes,
For
yes.
30, you have to minus 6. For 39, it's only plus 1 week, yes?
Yes. Yes.
It's only a 1 week difference. So the 30 week is less reliable, all right?
Yeah.
Why is it less reliable? Because of course, if I, for example, let's look at the example that you were discussing before about my O levels. So
Yeah.
if I determine from O levels to A levels, maybe my prediction can be correct because it's just a year apart, yeah?
Yeah.
But if I say I'm studying good in my O levels by studying at night and getting good grades, I will also get good grades in my last year of university. Then this is called extrapolation. Why? Because
Yeah.
this is a very far stretched estimate. Yes?
Yes. Yes.
Are you clear? All
Yeah.
right. Okay. All right. So these questions in 5B are all related to interpolation and extrapolation. All right.
Yeah.
All right. So we're going to stop here today. I want you to practice these questions before we can move forward.
Sure.
Okay. I'll just mark